Today we're going to talk about radicals. Radicals have two parts. The first part is the radicand, which is the number or expression that is underneath the radical. And then we have this tiny number that's sitting on top of the radical, and that's referred to as the index. Just like with exponents, radicals have a couple important properties that we're going to have to use in order to simplify. The first one is when the index and your exponent are equal to one another. So when your index and exponent are equal to one another, the radical simply cancels out and you're just left with x. So an example, let's look at an example using numbers. Let's say I had the cube root of x all raised to the third power. Well, essentially the exponent and the index cancel each other out, so you're just left with x for your final answer. Another property says if you have two radicals, so here in this case I have two radicals that are being multiplied together. The first thing to notice, and I wrote this down below here, is that if they have the same index and they're being multiplied, you can go ahead and combine it into a single radical by multiplying the radicands together. So let's take a look at an example. So let's say I had the square root of 2 times the square root of 3. Well, in this case, the index is an understood 2. So if I go ahead and multiply them together, I can combine them and simply say 2 times 3, so that equals the square root of 6. The last one's very similar to the one that we just talked about. In this case, we're given the radical is over this entire fraction. Now, this property works both ways. If the radical is over the entire fraction, I can actually split it up into two radicals. So I'm going to take the nth root of the top and the nth root of the bottom. So again, let's take a look at one using numbers. So let's say I had the square root of 3 over 4. So I could actually rewrite this as the square root of 3 over the square root of 4, which would be the square root of 3 over 2. We have two more properties to discuss. The first one is when we have a radical inside a radical. Now notice we have two index numbers, m and n. To simply combine this, just like we would with exponents, you're going to take these two numbers right here and just simply multiply them together. So you'll get m times n and then radical x. So again, let's take a look at an example. So let's say I had the cube root of the cube root of x. So again, all I'm going to do is take these two numbers right here, multiply them together, so 3 times 3 is 9, so that would equal the 9th root of x. Now this last property is really not a property, it's a mistake that a lot of people make. Notice if you have two radicals in this case, they're either being added or subtracted. Even though they have the same index, you cannot combine them into a single radical. In order to add or subtract radicals, which we'll discuss later, you have to have the same radicand underneath. Alright, before we get to an example of simplifying radicals, we need to go over three rules that are going to be important. Now, the first rule says a factor in the radicand is not raised to a power greater than or equal to the index. So what does that mean? That's basically saying that we cannot have an exponent that is greater than or equal to the index. If we do, that means we can simplify it more. The second rule is saying a denominator does not contain a radical. So that's basically saying you cannot leave a radical in the denominator. And then our last one is saying a radical does not contain a fraction. So that's similar to the second rule that we just went over. We have to split that radical up and then rationalize the denominator to get rid of that radical. Alright, In these examples, you're going to be asked to simplify the radical as much as possible. So the first thing you want to look at is what is your index. My index is a 3. So that means I need 3 of the same number or 3 of the same variable in order to bring it out of this radical. So first let's take a look at our 24. You're going to have to make a factor tree. So 24, to make a factor tree, I can split up 24 as 3 times 8. And then 8 is 2 times 4. And then 4 is 2 times 2. So if I bring everything down, I have a 3, a 2, a 2, and another 2. So remember we said we're looking for a group of 3. So notice I have 3 2s. So that's going to allow me to take a 2 out for my final answer. So I'm going to take a 2 outside the radical, and then underneath the radical, since I had this 3 right here left over, it has to stay underneath the radical. Now let's take a look at our variables. So my x's. I have 5 x's. So again, we're looking for a group of 3. So I have one group of 3, and then I have 2 left over. So since I have one group of 3, I'm going to bring an x out, and then I have 2 left over. So if I multiply those together, you're going to get x squared. That's still underneath the radical. Do the same thing for your y's. I have, notice in this case it's saying I have y to the third. So that means y times y times y. So I have one group of y's. Notice nothing is left over. So since I have one group of y, I'm going to bring a y out, and then nothing's left underneath the radical for my y's. Then you do the same thing for your z's. If I take a look, let's see. If I take a look at my z's, you're going to have 6 z's. And I'll put dashes through my z's so you don't get them confused with the 2, 4. Okay, and there's 6 of them. So you're looking for groups of 3. So I have one group of 3, and then I have another group of 3. So since I have 2 groups of 3, you're bringing 2 z's out. So that would be the same thing as z squared. Again, nothing is left over. Alright, I don't have any z's that were not in a group of 3, so that means nothing's left under the radical. So if I go ahead and write my answer all in one color, so my final answer is going to look like 2xy z to the second times the cube root of 3x squared. Now let's take a look at something. Instead of going through this entire process right here for our variables, there's going to be a shortcut. Notice you're going to take your exponent and divide it by your index. So in this case, 3 went into 5 one time. So that's why I brought 1x out. It had a remainder of 2, so that's why x squared is left underneath the radical. Let's look at our y's. I had y cubed, so 3 goes into 3 once, so I'll bring 1 y out, no remainder, so there's no y's left underneath. For my z's, 3 goes into 6 twice, so that's why I brought z squared out. Again, there was no remainder, so no z's were left underneath the radical. Alright, our second example, we're going to have to use one of the properties that we wrote down above. So let's take a look at saying the square root of the cube root of c cubed d to the 6 all raised to the 4th. Now, if there's not an index written, so there's no number written right there, it's an understood 2. So anytime I have a radical within a radical, remember you're going to take those two numbers and multiply them together. So if I go ahead and rewrite this problem, I'm going to get 2 times 3 is 6. So I get the 6th root, and then nothing changes underneath. I have c cubed d to the 6 raised to the 4th power. Now, we're going to build on our exponent properties that tells us you needed to go ahead and distribute that 4 to both terms inside the parentheses. So if I go ahead one more step before we simplify, we're going to get the 6th root of c to the 12th, d to the 24th. Now, this time, instead of writing 12 c's out and 24 d's, we're going to use our shortcut. So we're going to say 6 goes into 12 twice. So 6 goes into 12 twice, so that means I can bring c squared out. It divided evenly, so nothing's left underneath the radical. Do the same thing with our d's. 6 goes into 24 4 times. So I'm going to bring d to the 4th out. Again, it divided evenly, so nothing's left underneath the radical. So in this case, that is our final answer. Alright, getting into our last example for simplifying radicals. In this case, we have the square root of 12x to the 4th, y to the 5th, divided by the square root of 3x squared y. Now, the first thing you should notice is that in this case, they're both square roots. So my index is on the top and bottom are both understood to be a 2. So that means we can use one of our properties that says if we have the same index, I can go ahead and combine it into a single radical. So it's going to be the square root of 12x to the 4th, y to the 5th, over 3x squared y. Now by combining it into a single radical, now I can go ahead and simplify this fraction right here. Well, 12 divided by 3 is a 4. X to the 4th over x squared is going to simplify to x squared. Then if I simplify y to the 5th over y, that's going to simplify to y to the 4th. Now we still have the square root. Well, now it turns it into a lot easier problem. The square root of 4 is 2. Then if we use our shortcut, remember we have this understood 2 right here. So 2 goes into 2 one time. So I bring an x out. Then 2 goes into 4 twice. So I'm going to bring 2 y's out. So I'm going to bring y squared out. Nothing's left over since they both divided evenly. So my final answer is 2x y to the 2nd. Now the next thing we're going to talk about is rationalizing the denominator, which we've covered before last semester, but it's going to be in a separate video.